welcome everyone. So we're going to talk tonight all about version control with Git and GitHub. Before I start, a few questions for you. How many of you have used any version control system before? How many of you used Git at all? And beginner for Git? Intermediate? Anyone that's advanced and can teach? Okay. So my goal with this is to give you the basic stuff that you need for Git. Everything I'm going to teach is what I do all day long when I'm using Git. I'm not going to teach you all the crazy advanced stuff that you're probably going to Google it anyway, because I'm going to Google it. But it's all the stuff's going to be every single day, every time you want to do something with version control. Everything in here is what you're going to be doing and how it actually works. So we'll cover the whole, like, what is version control, why you should care in general, do the basics of Git, all the essential stuff. And then when we're done with that, we're going to get into getting social with GitHub. So GitHub is not Git, first off. If a lot of people associate GitHub with Git, it's kind of like car and carpet. Your car has carpet, but the carpet is not the car. So with GitHub, it uses Git behind the scenes for all its version management, but it builds a ton of stuff on top of that. That is not native version control stuff that we will see when we get there. So version control allows you to do a couple things. First thing is, it allows you to collaborate. So as you work as a team, you need to get other people's code. You need to be able to send them your code. But you need to be able to see differences between everything. So you can do all that collaboration with version control. You can track and revert all your changes as well, which is a huge thing. Back in the day, people did zip files and they called that version control. The version control is only as good as when's the last time you zipped it, which typically was like 2-3 weeks ago. And you go, crap, I deleted something I did a week and a half ago. It's gone. Version control gives you that ability if you're doing true check-ins. Check in early, check in often. But anytime it works, anytime it compiles if you're in a compiled language, check it in. There's no reason to hold it until you're done with the feature. Sure. If you do that, you're asking for trouble. So check in early often. It gives you all that tracking of changes. You can revert stuff back. You can merge in other people's changes really easily. Use the power to your advantage. I kind of love this slide. This is what it's like working without version control. So imagine on the left side Julia says, hey, I need milk, sugar, and eggs. Well, then she goes, talks to Mindy at the top. Mindy says, no, maybe only some eggs. Jerome at the bottom says, oh, I need flour. Well, then Patel says, oh, I need butter. Kim says, I don't want regular milk, I want soy milk. At the end, you're going, which one of these people? What's the actual list? It's kind of the game we all played as kids. You whispered in somebody's ear, and by the end, whatever was said had nothing to do with what you started with. That's what it's like working without version control. You can't keep track of the changes. It's up to somebody to remember what they were. Now let's look at the difference with version control. So it starts out still with, Julie says, hey, I need these 3 things. And then Mindy says, oh, I'm going to make an update. Jerome gets that, merges it in, says, I now need flour. Patel adds in butter. Kim says, I need soy milk, and at the end, you have one merged list. You know exactly what you need to buy. That's the power of version control. Taking all these changes, merging them together so you get a good output at the end, and you're not questioning what is the output supposed to be. So what should you version control? You can version control anything, but you should not version control everything. So there's a few things. For tracking, you do get to decide what goes into your version control system. You should leave some things out like I mentioned. Stuff like libraries. Stuff that, if it's done by a package manager and you're just going to install it anyway, the minute you check that in and somebody else checks it out and does the install, now you're conflicting with each other. Same thing for files. API keys is more of a security thing. You'd be amazed how quickly, if you check in your API keys, some bot has got it. Even if you catch it and go, oh, it was only there for 30 seconds, I guarantee you some bot caught it. Heck, the Google bot or the GitHub bot caught it. I checked in my GitHub key one time by accident, and literally I had an email before I was done with the push command, fully running. It was like, oh, you guys are monitoring that. Because when they get your API keys, now they can impersonate your application. They can impersonate you. You imagine it's your Amazon keys, and now they got the key to the kingdom. They can provision all kinds of machines up, and they'll do it before you even know it. So you want to keep certain stuff like that. API keys, database connections, all your security stuff should not be in version control. And one of the prime reasons for that, besides the security, is there's also a history. So even if you go, it's a private repo today, no one can access to it except the people I say. The minute you make that a public repository, the history's still there. I can quickly go search through the history of all your files and all your changes and see those keys anyway. So you should always keep them out of your repository. I bet you guys have already managed your work to some extent with version control and don't even know it. How many of you have files like this? You go, resume September 2013, resume for this job. Resume old, resume new, really, really new. It's like all of us have done that. So we basically created our own version control system. So version control has been around for years. So I started CVS. Their version control existed all the way back in the 70s and 80s. Those systems are long gone. So briefly we had CVS in the 90s. It's still around. You can still use it technically. SVN came along. It was just like CVS was. It gave us one humongous difference. CVS, every single file that you checked in was its own individual commit, which sounds okay until you realize if you need to revert one, you have to go find every one of those commits to revert that change. It didn't commit them all as a set. SVN's major thing was it committed all of those as one set. So if I needed to revert, all I had to do was revert the set back. I didn't have to go back and go, hey, these 30 files, I got to find 30 commits now. Nope, you just had to find the one. And then Git, well, it's Git. It's become super, super popular. We'll dig into Git here. So version control type-wise, we did have two types. The centralized version control is really what CVS, SVN, all the old Microsoft stuff like Visual Source Safe and all that was all based on. And essentially it meant you had a central server and you had to communicate back and forth to that. And distributed is the exact opposite in what Git's based off. There technically is not a central server. GitHub acts like our central server, but we don't have to do all that same interaction. We can do stuff just locally. So here's a little diagram of how the centralized version control worked. So essentially what we had is the very top, we had that central repository. Anytime we needed to do anything for it, I need to get changes, I need to commit history, I want to look up logs. Anything you need to do, you had to be online so that you can communicate back and forth with that server. There was no such thing as offline. In a lot of cases, those servers, you had to check out the files and say, I'm editing these. So all of that online stuff made it really difficult to have stuff locally. Like, say I'm on a plane, I want to do some changes. Well, I can't commit anything there because I can't talk to the server. So everything I've done in that offline time becomes one big commit. Where Git works very different. We still technically can have a central repository, but we also have local repositories. So everything I can do up at the central repository, I also get that same power on my laptop. So I can totally disconnect from the network. I can do all the commits that I want to do. I can keep track of all my history. I can look up all of the history of previous commits. I can merge files together, see history of files. I have the full repository sitting on my machine. The nice part as well is because I have the full repository, if that central server gets corrupted or blown away, everybody that has a version of the repository has a full repo, and any one of those can get either pushed up back to the central server and fix the corruption, or you can turn that machine into the central repository. And that's exactly what Git does for us. That's also what pull requests kind of do. And when we get into the pull request and forking, we'll talk a little bit more about having our own copies and multiple copies and all that. So at this point, why do we really care about Git? Biggest thing is it tracks changes. We can undo all of our mistakes. We can work offline. And we can collaborate on code much easier. It is so much easier to merge stuff together than it was with like SVN and all the other stuff. It used to be back in the day, you would create this patch file, email it around, and hope somebody would merge your code back into the repository if you didn't have access to it. Now with GitHub, I can just click on the button and boom, there's my patch. Same thing for just the Git client. I can merge anybody's code in. It's one simple command, none of these crazy patch files that I have to send around. There's some major vocabulary that we do need to know. First one is repositories, or repos as a lot of people call them. All that is all the files you want to track. Nothing more than that. Branches aren't really any different than any other version control. It's a separate line of development that has its own history. A commit holds everything for a single change. And a commit is strictly on your machine. It doesn't get sent up to the repository yet. And then head is the most recent commit for whatever branch that you are actually on. I do see a ton of you taking notes. I will give you the link to these slides. They're all on GitHub actually right now. So you'll be able to see all of them. So how do we get installed and set up? Everything tonight's going to be through the command line. I'm a big command line user for Git. And it's because it's so simple. There's only like 5 commands that I consistently remember. Maybe 6 if I start getting into some logging stuff. But your basic commands, not that many of them. And I find a lot of the UIs abstract all the Git stuff away. So that when you go to somebody that doesn't have that exact UI, you go, I don't know how to use Git. It's like, well, learn the command line, and then you can find a UI. So first thing is that git-scm.com is where you can get the latest Git command line. Once you have that installed, it's like 60 megs to download and like a minute to install the thing. There's 2 major things you got to configure. Here, what is your email address and what is your username? And typically your email address will be whatever your GitHub account is, or the email you want all of your commits associated to. And so every time we do these commits, it's going to associate it to whatever name you've configured, and it's going to have the email address after it. Here's probably the most important slide if you do commits and you forget to put the -m for messages. It uses VI as its default text editor. If you've never used VI, you'll never figure out how to get out of it. Because it literally gives you a window, and you're like, where did everything go? But it's I to int, which goes into insert mode, so you can actually do all your editing. When you're done, you hit the escape key to exit out of insert mode, get you back into what they call command mode. Then :W will save the file, :W exclamation point will override and save the file. So if you give some error and you just want to force override, and then escape :Q will quit out of VI and give you back to your command prompt. There's also, once you get the slide deck, the instructions here actually has a link to set up, I think it's, let's see, Sublime, maybe WebStorm, and like one other, maybe Atom, on the GitHub docs to change it out of VI to that editor, which is a little bit nicer, but by default, it is VI. So those are the 3 commands you kind of need to know to get around VI. So now into the fun part. Most of the rest of this is going to be showing commands and how to actually initialize repositories, add files, do commits. Once we get into the GitHub space, we'll get into actually pushing the code off of the machine. So first thing is to pick a directory that you want to store files. You can store it either in your home directory. I typically create a projects folder and store all my code in there. Make a directory for your repository, and then git init just tells Git, take this directory, initialize everything up so that it thinks it's an actual Git repository that I can do all the commands against. And then git status will show you what is the current state of your repository. Do you have files that aren't added in? Do you have commits you haven't pushed up? Is it nothing in there yet? And so at this point, if we ran git status after the git init, it just says we're on master branch. We have our initial commit, and there's nothing yet to commit. We haven't added any files yet. So adding files are really easy. If we were to create say a hello world text file, and we run git status, we'll get something like this. It will tell us we're still on our master branch, we're still in the very initial commit because we haven't done anything yet, and we have one untracked file. So Git has this notion of tracked files where I have to tell it which files I want to add into the repository. By default, it doesn't add files unless you tell it. And so every time you run git status for a new file, it'll be in the untracked files. And to add it in, we say git add, give it the file name. And now instead of it saying, hey, we have uncommitted changes, now it'll say we have changes to be committed. So it's a two-step process in Git to get all of your revisions. You first have to add the file, and then we have to actually commit the file. And so committing is nothing more than making some changes. Let's see. There we go. That's the slide I want. So once we add it in, the git commit actually says, now I want to store everything that's in that files to be tracked or files to be committed section. The -m is the message I'm going to associate with it. If you forget the -m, that's where it'll open up the VI editor for you. And you can type the same message, and it'll do the same thing. And once you commit it, you'll have something like this, where it'll give you a hashtag. That's what the D1BE922 is. That's the unique hash that's associated to this version. So I can always get back to that version by whatever that hash is. Then it gives me the message, and it tells me I changed one file, and I used create mode for it because it was a brand new file. So now you'll also notice, say I made a change to the file before I committed it. You'll see here, I've actually got a changes to be committed, and I got a not staged commits. So if you add the file, and then you go back and you make a change to it, you have to add the file again to get that change in there. Every add says, I want to store it exactly at this point in time. And that's kind of cool that it'll allow you to do a commit at individual changes. So just be aware that's where I run git status a lot. You'll see it a lot through this presentation. Git status is your friend. It's a way to make sure you know, am I checking in everything? Did I forget to do a git add on something? Am I checking in something I shouldn't? You know, a lot of times the reason people check in API keys is because they do the blanket git add everything in the directory, and they forgot to tell it ignore my API key, and then they just commit it. If you run git status before you do your commits, you'll know exactly what's going to be committed in there. So we did a whole bunch of stuff here. So the first thing we did, we used the add command, told Git, I want to track this file now. Then we did a commit to tell Git, actually save the changes. And then as we saw with the status, it shows what state I'm currently in. So all of this is tracked as well in our history. We can get to our history with git log. It's pretty verbose. It tells us what our commit hash is, who authored it, what date it was authored, and it tells you your whole message there. And the very last line, I guarantee you, will not show up. That's because it's an HTML slide deck and caught the email earlier and thought it was a closing tag now. How nice of it. There's different ways to do logs. Aren't so verbose. It's like git log -- one line -- graph -- decorate will show us one line for each one of our commits, and then it will actually indent them if we have branches that get merged back in, pull requests that get merged in, so we can easily see what all the changes are. If I take out the graph and the decorate, it'll just give me a big long list on one line, and it'll give me the nice short code for it. Of course, I don't have a hash. The hashtags are GUIDs, so they're like yay long, but you only need like the first 8 characters. So that's why you see only 8 characters in these short ones. So the get one line is just a quick way to do a glance at exactly what the message was. And you can get a lot more history. And you can imagine once you get a repository that's pretty busy, having something that looks like this for every single one of the commits, they're going to be scrolling for quite a while in your command window, versus -- one line will give me just that top line format, and I can get, on this screen, I can probably get 40 commits on it before I have to start scrolling. So I said we can undo our changes earlier, because nobody's perfect. I can't count the number of times I've undone local changes. It's really easy to undo changes that you have not staged yet. You do git checkout, you give it the file name, and it will revert back to whatever the previous version that was committed to Git. You can also undo save or stage changes. A little bit more work in this one. This time after you've added the file in there, you have to do a git reset head and give it the file name. That puts it back into the unstaged files section. You still have your changes in there. It hasn't gotten totally rid of them. If you need to back all the way back out, you can do git checkout, just like we did in the previous slide, and it'll get you back to what GitHub or Git exactly had. So this can be useful if, say, you added in more files than you wanted, because your commits really should be pretty autonomous. Because you shouldn't be saying, hey, I'm going to go do a database connection, I'm going to do a UI thing, and I'm going to do this other thing and this other thing as one commit. Those really should be individual commits. Your commits are supposed to be single-purposed commits. So sometimes you might accidentally add in one more file than you need. You do git reset head. That'll take it and put it back into your unstaged files. And then you can do your commit, and then you can re-add the file in there. So pretty powerful with the reset. Technically, you can't undo committed changes. There is no such thing as a undo committed. What Git does instead for you is when you add the file, you commit it, then you have to do the git log so you can get that hash code. You basically tell it git revert hash. It goes back and looks at what was the previous version before that, and it makes a new commit with that version. So it never truly reverted it. It's still there in the history for you. It just took that previous commit and stuck it as the very first one for you as a brand new commit. So no such thing as truly undoing and reverting in Git, which makes total sense because you don't want to totally dump something you've already committed because you don't know, did that thing get pushed to somebody else's repository? And if it truly deleted them and somebody else had the repository, now you've screwed up their history, their repository becomes corrupt, so they don't have that option. Instead, you get to revert. Deleting a file, pretty darn simple. It's git rm, you give it the file name, and that will remove it out of Git next time that you do a commit. Git is also really good if you delete the file off the file system. It'll show that it's deleted, and once you do a git add for that file, it'll stick it in the deleted state for you. It feels kind of funky that it thinks it's deleted, you do a git add and it still wants to delete it. Git add just says track this file in whatever state it's in. So the git rm is, I still have the file on my system. I want to get rid of it. But the git add in the file name, it's already gone. Then you can actually get Git to leave it as deleted. So ignoring files, we talked earlier, you don't want to check certain things in. So they have this concept of .gitignore. So anything that you put in that file, when you run all of these git adds and git statuses, it's not going to show those files or those directories in the available things to add in. So you can do single files, you can do full directories, you can do wildcards for file names, you can do full wildcards for directories, all that stuff's supported, and it's just a text file that Git uses. And then you want to make sure you check in your .gitignore file to Git itself as a version file, because everyone needs the same file on their system for your project. That way they leave all the API keys and everything else out. Questions on basic stuff before we get into branching? So what is staged and unstaged? So when you do a git add, it sticks it into this staged area that says, when I do a git commit, all the files in staged are what's actually going to be committed as a version. The unstaged is all the files you haven't told Git to add or to track yet. Any other questions? So branching. So as a beginner for Git, branching feels a little advanced. but it's really not. It's kind of a standard way that you will work in a lot of cases. It's a way to develop different code on the same code base without impacting your existing code. It's like exploratory work that you may want to do. It's great for, hey, I want to go off and try this proof of concept thing on our project, but I don't want to impact anybody else. So you create a branch, because it's got its own history, everything you do in this branch doesn't affect anything else besides that branch. And then whenever you're ready, you can decide to merge changes from that branch back into your master branch, or you can decide, I don't want to do anything with the branch, I just want to get rid of it. The one thing that they do say for branches, you don't want them to stick around for long periods of time. Once you get them sticking around for long periods of time, you start to get a lot of differences between your main code branch. And so you should use them, get rid of them when you're done with them. If that proof of concept doesn't work out, get rid of the branch if you're not going to need it any longer. Creating branches, really simple. Git checkout -b tells it, I'm going to create a branch and I want you to check it out. In this case, we're going to call it version 2. Then everything I normally do that we've been talking about, I get all the same commands. It's just, now instead of being right here on the master branch, I'm over here on the version 2 branch and everything's going to affect that and the master's going to stay exactly the same. I can have as many branches as I want. I can also pull in other people's branches. So when we start getting into the GitHub space or spaces where you're working with multiple team members for remote repositories, each of them can have their own set of branches. But because they're all put up to GitHub, at the end of the day, you can also pull all of them down, check all of them out. And so when you run git branch, it shows you all the branches you currently have. The star in this case is your active branch. So I know right now, because previous slide I said git checkout -b version 2, I'm on the version 2 branch, and that's why it's starred. If I need to switch between branches, I take out the -b. The -b is strictly to say, create a new branch before you check it out. So in this case, master already exists. I do git checkout master. Now I'm on the master branch, and it'll tell me I switched over to the master. So notice there wasn't a whole lot to branching in general. Branching really is just creating the branch and using it. The next piece is merging. So I've got to be able to get my changes from one branch to the other. And so the first thing I need to do is check out whatever branch I want to merge into. So in this case, I want to merge my version 2 back into the master branch. So I need to check out the master branch. Then I run the command git merge and tell it what branch I want. Git will go through, look at all the changes that I have, and merge them together where it can. Sometimes it cannot. So imagine that I change the same exact line on master and on version 2. So what you end up with is, when I run this git merge, I'm going to get something like this where it says auto merging of it, then it's going to say conflict. Git doesn't know which one of those two should win. It's not last in. Instead it goes, hey, you both changed the same line, you have to interact with me and you have to tell me, how am I going to fix this? What's the right version to actually fix? And if you do the git status at this point, you'll see that it says, hey, you have unmerged paths right now, and it'll tell you both branches modified hello_world text. If I open up that file, I get these crazy little less than and greater than signs. So at the very top it says, on the head branch, which right now is the master, or sorry, is the version 2, it says, here's the change you made, which is in yellow, and then right below that, there's the master changes. I have to figure out which one of those to keep. And I do that by deleting which files I want. Say I want to keep both lines. I would delete line 1, 3, and 5. Because I have to get rid of, all, at the end of the day, that first line that has all the less thans, then the head tag, all the equal signs, and the greater than master. Those are all the tags it puts in to tell me the differences. Once I get that done, and we do our git add, we do our commit. It'll say, hey, we merged our master branch, or merged branch master into version 2 in this case. And now we're back to where we needed to be. And Git's really, really good about auto-merging stuff. And the amount of times that I have to do a manual merge is probably 5% of the time. Because typically you're working in a team and you guys kind of know, okay, you're going to work on this piece, I'm going to work on this piece, and you're not clashing a whole lot, but every so often you have pieces of shared code where both of you add something into the file, maybe not the same lines exactly, but what ends up happening is when they merge together, Git goes, oh, I see this line and this line look like they're different on both files, when really it was, hey, I just added a function here and I added a function here. You just happen to catch the same exact line in the file. So it does happen, but most of the time, it's really good about detecting and merging automatically. So before we move into getting social, any questions on just Git in general? So is git shell just the git bash command prompt, or? So it looks something like let's do git bash. Something more like that? All right. Yep, so it's basically a command prompt. Is what that is, all that is. Git bash comes with the git install. So people that are really familiar with bash and Linux scripting love git bash. I've been a Windows user for so long, I've never been a bash user, so I just use the regular Windows command prompt, but I also don't have a ton of shell scripts. So both of them work, all the commands are the exact same. Nope. Now, at the end of the day, it's all the git commands that we showed will run on any command prompt. Yeah, that's one of the reasons I do the command prompt and not the UI, because a lot of UIs you'll see a sync button, and I always laugh when I see the sync button in UIs, because there's no such thing as a sync in Git. That's not a Git concept. What sync is really doing is saying, go up to my remote repository, fetch everything, bring it back down, merge all the changes in, and then push all the changes back up to my repository so that you get everything back in sync to what's remotely at GitHub. So there's not a concept, it's a bunch of commands hiding behind the scenes for you. So you go to the command prompt and you go, git sync, and it goes, that doesn't exist. So I like command prompt. Other questions? It does not. So when we get into getting social with GitHub, we will cover that exact piece. Up to this point, everything is local on this laptop. Nothing's been pushed off the laptop. That's one of the powers of Git. I get all of the power of version control without having to have that central repository at all. So we haven't created a central repository. When we get into GitHub, that's where we'll create our central repository, that once I push this code up there, all the rest of you can get it. Right now, unless I gave you my IP address, actually, even if I gave you my IP because I'm not running a Git server, there's no way for you to get my Git repository off of here. I would have to zip it up and send you it, which defeats the purpose. So some text editors have Git functionality built in. Yeah, so like I use Visual Studio Code a lot. They actually have Git integration in there. Sometimes I use it, sometimes I don't, but I know WebStorm also has Git integration in it that will do all the stuff for you, so you get a little bit of a GUI baked into it. I still tend to use the command line. I just find it faster. Because even when I've looked at like the Visual Studio Code stuff behind it, they'll show you the output window, and it's running so many Git commands. I'm like, wait, all I wanted you to do was add, commit, and push. Why am I seeing like 7 or 8 commands and wondering why it's slow? And I haven't dug in enough to see what are they really doing behind the scenes. And I find a lot of the UI integrations running all kinds of other stuff because they need to keep things in sync for their editors that I don't have to run. But the editor is nothing more than saving files on the local file system. You still have to interact with Git, whether it's the command line or whether it's a GUI tool. Yes. So the ability to actually use a UI to do all the merging, yes. You can configure Git to do beyond compare or any of the other merging tools that are out there. There's lots of tools. There's even one built in to Git. If you do git k and give it a file name, it'll actually show you the history and show changes. And so there's all kinds of options there. So yeah, if you do a quick Google search for setting up the Git diff tool, they'll give you all the commands for right off the GitHub docs for setting up all of the common ones. I have not set those up because I do so infrequently do I actually need to do merges and stuff. Lately, I've actually been using gitkraken when I've needed to do it because their editor is pretty fantastic for that. Gitkraken's free for open source and created by a local company called Axosoft. I would look at that one unless you already have beyond compare licenses. So gitkraken is free for open source. I think it's $60 a year for commercial license. Every directory is its own, every high-level directory is its own repository. So every project would be a Git repository in itself. If you're trying to, if you do a Git init at say like c/projects, well, it's going to think every single project you have under there is going to be under the same exact repository. And so that's not the case. Instead, you would create a directory like project 1, project 2, project 3. Each one of those you'd go inside and do a Git init. So if you delete there's a folder behind the scenes called .git. So in Windows you can turn it back on. On Mac, I know there's a way to turn on hidden files. Typically the .git is a hidden directory. If you delete that directory, Git no longer tracks that directory at all. Even if you're tracking it up in GitHub, you just told it locally, I'm not going to actually track that as a Git repository. Then you can do Git inits or move it to the right spots. Also do your Git inits. Other questions? So getting social on GitHub. This is the place where you really do get to share your code. And there's lots of code to share. They have over 8 million users, over 19 million repositories up there. So there is tons and tons and tons of code. It's a place you can host your repositories both publicly and privately. Publicly, it's free. For private repositories, it's $7 a month for that, for individual accounts. And all the private gives you is the ability so that if I go search your user account, I don't see that show up in the list. You have to specifically give me access to that repository to get into it. Even as a read-only, you have to give me access. Most open source projects these days tend to host their source code on GitHub. And the primary reason you'll see coming up is when we do patches. It is so easy to do patches. It's like 3 buttons and you fill out a little text box to say what the heck you're changing and you're done. And then they get the request, they can review it, they can decide whether they want to merge it in. It's both easy on our side and easy as a maintainer of a project to merge stuff in. It's a place for you to publish your own code as well. So I've got all kinds of stuff up there. My blog's up there. I've got like all my talk demos. Anything that's kind of cool that I want to keep track of. Tons of stuff where I've got other people's code in there, which when we get to the forks, you'll see some of that power. I also use it a lot to learn and read and copy from other people's code. You know, it's a nice way when you find something that works, you can dig through all the source code. But it's right there, you can see all the history, you can see how they came up to stuff. You also see issues. So it's really nice when you come across a project and you're like, oh, this looks really cool. Then you look up and it goes, oh, it's got 50 issues. Let me see what the issues are. Sometimes they're questions. Sometimes you're like, oh, that would actually impact me. I'm going to skip this project. Sometimes you might be able to even help out with it. And then you can do contributions to open source. Because of the pull request model, it's super, super easy to do open source contributions. And we always think of open source as hey, I've got to actually do some coding, you'd laugh at probably half of my open source. My Angular 2 pull request, custom contribution, was the best pull request ever. I changed a semicolon to a colon in their docs because they had a code example wrong, and I was using it and went, this is really annoying. I spent more time filling out their docs to get it approved than I did actually submitting that. But next time I go to use that little code snippet, it's right in their docs. So it doesn't have to be this elaborate thing. I've done that for a lot of different projects. I'll come across ReadMe files where I'm like, hey, I know how to use like Chocolatey, like the native script one. They use Chocolatey for their install for that. I own a couple of the packages they use. I went, hey, that install command's changed. You don't need this. You don't need that anymore. I can quickly just update their docs for them and send them requests. So easy ways to do contribution. It just doesn't have to be code. So remind me again, how many of you actually have a GitHub account already? So most of you have a GitHub account. Awesome. If you don't, it's like maybe a minute to log in. You literally fill out first name, last name, email address, give it a password, and you're done. Once you're logged into your account, you'll see this little plus sign with a drop-down arrow. That's where you can get to being able to create new repositories. And I'll give you a screen similar to this. You give it a name. In this case, we're doing hello-world. You tell it whether you want it to be public or private. If you don't have a credit card on file with them, the minute you click on private, it will ask you to add a credit card in for them. But it is really nice that by default, it does public. It doesn't ask for the credit card until you tell them you want something that's paid. And then you can choose to initialize the repository with a little README file or not. So if you've already got a directory that has all your Git stuff in it, you don't want to initialize your repository on GitHub, because all you're going to do is cause a merge conflict. It's going to go, hey, you've got changes up there that you haven't pulled down here. So I always leave that unchecked. I almost always have the repository locally, and I'm going to send code up to them. For our local repository, there's two commands that you need to give it the tracking for Git, or GitHub, sorry. You do git remote add origin, and then you give it your repository name. So the convention is github.com/your GitHub username / your repository user. So in my case, my GitHub name is DigitalDrummerJ. Okay, and then the repository name that we saw on this previous slide would be hello-world. That tells Git anytime I want to do push commands or I want to pull changes, where to go to by default. Origin is always going to be the default place that stuff goes that if you don't specify. So then our very next command, because we just added the remote repository and we haven't finished setting up tracking, we have to say git push -u origin master. That tells Git, I want to now track all of my changes, and this is the location they're going to be tracked to. You only have to do the -u the very first time that you do the push. And now, if you were to go back to that GitHub repository, refresh it, you would see all the files that were on your machine now show up on the website. If, say, you didn't have a local repository already that you were adding up there, and you just wanted to start by pulling down the blank repository, when you click this button at the very bottom for the create repository, it'll give you a screen with all of the commands. There's two commands in front of this. It's literally like git init, add a file, add the remote like we did, add the push, or I can do a git clone, and it'll pull everything down for me. And we'll see cloning in a few minutes. So README files. They're not forcibly required, but they're highly suggested. If you put a project up there that you want somebody to contribute to, you need to put a README file there. Because this is what's going to describe what is your project to me, how do I use it, how do I get it installed for development, how do I get it installed to use, how do I actually contribute to the project. You may have standards that you want people to follow, certain ways that you want them to have their commit messages in there. You may want them to open up an issue and get approval before they actually start working on changes to make sure you're not already working on the same changes. So by having that README file, that's what shows up when you go to a GitHub repo and it pulls up that big long document that you're reading through, that's the ReadMe file. So definitely want to add that in. If you're just throwing stuff up there, like my blog might have one just because the place I cloned it from originally had a ReadMe, but I don't expect people to do pull requests and contributions to my blog, so I don't bother to fill out the ReadMe file for that. It's like you don't need it if you're not going to expect contributions or want them. But if you are, definitely got to have it. So I mentioned the cloning earlier. So cloning is the concept of getting a local copy of the GitHub repository. So now that we've created our GitHub repository, or say we went to a new machine or one of you wanted to pull down that hello-world, you would go to whatever directory you want to pull it into, you run git clone, you give it the full repository name, and it's going to create the directory called hello-world. It's going to pull all the files out of the repository in there, and I'm going to have the local Git repo on my machine just like I created it from scratch. All the history will be there, all the branches, I can do all the other commands that we've talked about for today. And then sending changes, we've already seen a little bit how to send changes with the git push-u. So this time we add a file, we do our status to make sure we're good, then we do a commit, give it some message, do a status to make sure everything truly got committed and I didn't have some random file. You'd be amazed how many times you do a git status after you've committed one file and you go, oh, my editor behind the scenes, I opened it and it reformatted something and saved it for me because some setting, and now you have an untracked file. So I always do a git status before I push to make sure I truly got everything up there. Then I just do a git push. I don't have to put any place for it by default. It's going to do origin in whatever branch I'm on. So in this case, I'd be on the master branch. Git push will send all my changes up to GitHub on my master branch. And then I can just do a git status to make sure I don't have any pending changes. So it will tell you if you've done a commit and haven't pushed, it'll say you have X number of commits that haven't been pushed up yet. So you can see all of that from the git status. So say one of you is actually working on the repository with me, and I need to get changes. First thing I always suggest to do, commit your changes before you pull down local changes, or pull down the remote changes. You'd be amazed how many times somebody doesn't commit something, they do a git pull, and something they were working on accidentally got overridden, and they didn't even realize it. And then they can't get the changes back because they never committed them. You have to commit them in order to get your history. So commit your changes, then you do a git pull. Git pull is the way to tell, go fetch me all my changes and merge all of them into whatever branch I'm currently on. Then I can do any of my fixes. If it auto-merged, awesome, I don't have to do anything. It'll automatically create the commit for me. And then when I'm ready, I can just push all those changes back up to GitHub with the git push again. So git pull is really the major command. It's the fetching and the merging for you. So next concept is forking. Think basically two divergent paths, not the fork that we eat with. So forking is the way for you to contribute to something. So like in the case of the Angular 2 pull request, I don't have access to the Angular 2 repository. I can't directly commit anything in there at all, nor should I be able to. I'd probably totally break it. And so the way to get around that, I have to create a fork of it, which basically creates me a copy of the repository underneath my local user account. And then I can just do anything I want with it. I could totally have my own version of Angular 2 and make all kinds of changes if I truly wanted to. And it doesn't impact the Angular repository whatsoever. It only impacts my repository. And to get the local copy of the fork, it's just like getting any other repository. I say git clone, and then I give it my username, and I give it whatever the repository name. And in this case, that last let's practice forking actually goes to a repository called tiny-repo. So git clone, and if you noticed, we've pulled all of our own repositories, we've pulled all of our forked repositories. I can pull anybody else's repository. I don't have to fork them to pull it. Git clone is just a way to say whatever URL I give it, go ahead and pull down that Git repository onto my local machine. From there, it just depends on what permissions you have. If I pulled somebody else's repository and don't have permissions, I can never do a git push because I can do everything else up to git push because I don't have access. If you own the repository, you can push. Here's the thing that gets you as well when you start talking about forking. We technically have 3 copies of our repository at this point. We have the original one, which typically, from a nomenclature standpoint, they call it the upstream. It's where did this repository come from? The next one's my fork, which we refer to as the origin. And then we have my local repository on my machine. And we get all the same features, all the same history, everything. It's just a matter of who owns what. One of the things you have to do when you fork is at some point you're probably going to sync all of the changes that from the upstream repository into your repository. Especially if you're going to send them a pull request. They get a little ticked off at you when you send them a pull request and you don't have all their latest and greatest changes. Just because sometimes your stuff will actually break the builds. And immediately if you break their automated builds, you're never going to get merged until you fix it anyway. So the way to fix this is you run git remote add upstream and you give it whatever URL you originally forked it from. Then from there I can do a git fetch upstream, pull in all the changes, and then tell it where do I want to merge. So I want, for the current branch I'm on, I want to merge the upstream master branch into my current branch. And then when I do a git push, it will sync everything back up into my GitHub repository. And when you're on GitHub, you can also see right below, or I think it's actually right above the drop down for the branches, it will tell you how many commits you're either ahead or behind the remote repository that you originally forked from. So it's a great way to know that there's changes that have been made. In this case, once we do the git push, it'll say I'm even with wherever I forked it from. So that's a great way to know, okay, now that we're exactly in sync, now I can go ahead and I can do all of my changes. I can do all of my testing. I'm guaranteed I have the latest version. And it's a way to not have to delete my fork and recreate it. I will warn you, there are times, if you get far enough behind in a fork, say you forked something like a year ago, because you wanted to keep it, and then you go, oh, I found a bug in it. It might be a little hard to merge in a year worth of changes. Sometimes it's easier to go, I'm going to delete my fork and I'm going to refork it. Just because you delete a fork doesn't mean you can't refork it. You can't get that version back that you originally forked, but you can refork a new copy of it. So how do I get changes back into the original repository? It's what they call pull request. It's also short for PR. You'll see a lot of times people will just refer to it as PRs. They're really talking about pull request. Starting a pull request, super simple. You go to your repository on GitHub. There's no way to do pull requests from the command line. You have to do it through the GitHub interface. It's right on your repository is a pull request button. You click it, you get a screen similar to this. It'll ask you, what was the repository that you're currently at? What branch are you currently at? And where do you want to merge in? By default, it will actually pick the original fork for you. And then you tell it, what's the description I'm going to send you? And then all the details. Now, the more you write in the details, and it accepts full markdown for the details, the easier it is for whatever maintainer you're sending it to figure out what are you actually changing. The other thing you'll see here is we've got 2 tabs. I was right next to the little octocat, or right above the octocat. It says new pull request, actually 3 tabs. Then we get commit, and it'll show you every commit that's part of that pull request. So it's going to be every single commit that you've made on that branch that you haven't sent up to them. And then it'll show you every single file that's been changed. And you can see all the changes for each individual file. It's a great thing to look at. What am I actually going to be sending them to make sure you're truly sending them what you think you're going to be? Then after this, literally you click a green button that says send pull request, and the maintainer will be notified, hey, somebody submitted a change for me. Then as the owner of the repository, I'm going to review and decide, do I actually want to merge in this pull request? Does it meet my standards? Does it fix whatever bug? Does it add in whatever I needed them to add in? It's totally at the discretion of the repository maintainer. or an owner, whether they merge it in. Just because you send it to them does not mean they will merge it in. That's why it's good a lot of times to actually send them a note or open an issue to say, hey, I want to fix this. Or if you see an issue that's already been opened, put a comment in there that said, hey, I'd like to work on this, and wait for them to respond back before you start working on it. If they also ask you to make changes to your pull request, any change that you make onto the branch that you sent them the pull request from will be automatically included in the pull request until they merge it, which is kind of nice and kind of scary at the same time if you're not aware of that. So every time you do a git push until they merge your pull request, every single change you keep adding into that branch that you base your pull request off will automatically be included in the pull request and will start showing up in that commit tab. Because a lot of times you will have to make changes. They'll want either test written or they'll want doc changed. Something they'll want changed. That's the way to do it. There's also a link at the bottom of the slide that GitHub has a whole collaborating tutorial that walks through tons and tons of stuff around and how to actually do pull request. So before I hop into questions, a couple other things. I don't have them linked in the slides, but egghead.io has a 38-minute free course on making your first open source contribution that walks you through doing all of the pull request here. It's a great course by Kent C. Dodds. That is totally free to use. And questions on GitHub or Git in general? Yes, so if I go back and see, so that little cat is called the Octocat. That's kind of their mascot thing. So you see all the GitHub stickers all have the cat on them for the most part. Anything somebody wants to know about GitHub? Any other random questions in general about coding? Ooh, that's a great question, and I do not know the answer to that actually. I do not know when GitHub actually took off. Git started really taking off. For me, it took off about 4 or 5 years ago for Git, and GitHub wasn't that. Might have already been there. It's been there. I've been doing contributions for the last 4 years, and it's been there the whole time. I think the primary reason it took off is because the interface is so easy to use. It really opened up the social coding model. A couple of things I didn't cover at all in here is GitHub has an issues tab where you can actually log issues that you found. Most repositories and open source projects do ask you not to submit questions there unless it's truly relevant to, hey, I'm having some issue and I think I found a bug. But a lot of times they'll point you to Stack Overflow. But you can see all the things that people have found. Hey, I can't get this working. You can create your own. You can reference issues when you open pull request or commit issues. And so lots of power in that kind of collaboration space and seeing where projects are going and having the ReadMe files that people have and all the Git hooks so you can set up like continuous integration. Like I use Travis CI because all my repos are open. But Travis CI is totally free to do continuous integration. Like that's how my blog actually gets published. The minute I do a pull request from my scheduled branch to my master, we will kick off the continuous integration of Travis's monitoring GitHubs. All that kind of stuff made it so much easier for open source. I remember trying to do open source in the early 2000s when there was no GitHub. It was sourceforge.net and it was painful. Like you could SVN the code down, but then you had to figure out where's the issues track. They were never in SourceForge. They were some random place. You wanted to submit a patch. You had to figure out how do I get this funky patch file and how do I send it and how do I communicate? And so GitHub fixed all of that stuff. And there's competitors to GitHub. There is Bitbucket. There's also GitLab. All of them kind of have very, very similar features. All of them use Git behind the scenes. So you still get issues with Bitbucket and GitLabs. You still get, at least they have pull request with GitLabs. They actually call it pull request. Bitbucket calls it something totally different. They don't call it pull request, but all the same features are there these days. If there's no more questions, I appreciate you guys coming out. And feel free to follow me on Twitter. I'm at DigitalDrummerJ. My website's digitaldrummerj.me. Thank you.